Hey guys, I've got another battery damaged 386 board for you today. It's a 386 DX40. We've got a socketed chip. There's four 30-pin SIM sockets. They've got those beautiful metal clips. That's always good to see. Now, of course, this one did have a Varta battery. Thankfully, it was removed by the time it got to me. But that battery had indeed leaked, and as you can see, it's caused some damage in the vicinity of the keyboard connector. Now the seller indicates the board does post, but the keyboard is not recognized. So really that's a decent place to start. We got some sketchy traces leading down to the keyboard controller. They may be okay. Some green crusties on this logic chip here. And it's a similar story on the back. There's some traces along the edge of the board that appear to have been damaged by the battery electrolyte. They may still be okay. I'll clean them up and run a continuity check. Yeah, but these two are almost definitely damaged. They're directly underneath where the battery was, on the underside of the board, of course. So let's install a postcard keyboard and a monitor on this one and see what it does. And yes, indeed, it does appear to post. And we've got video, but we do not have a keyboard. Okay, so let's take a look at some of those traces. I've treated this area with vinegar to neutralize the alkaline battery electrolyte. If you look closely, you can see some bubbles there where the vinegar is reacting with the electrolyte. Jumper is just fused on there with corrosion. And here we are after the vinegar has done its job. I'm going to take a toothbrush to that and clean off the remaining corrosion. And then rinse all of this with isopropyl alcohol. Of course, we don't want to leave the vinegar on there for too long because it will damage the traces just as badly as the electrolyte would have. And then on the back, yeah, we can see those two traces are probably broken. The ones leading down to the keyboard controller appear to be okay, though. Okay, so I've removed the power connector and the keyboard connector. And the keyboard connector itself is just plain roached. You can see the remnants of one of those traces clinging to the underside of the keyboard connector here. And those two traces going to the keyboard connector, yeah, I don't think there's any copper left there. That's all oxidization. I'm going to treat that with some vinegar, of course, and see if I can scrape away some of the corrosion. Now, of course, this is not the best tool for the job. It's really just the first thing I had at hand. Once that vinegar has done its job, I'm going to flush that off there and probably use a Dremel with one of the rubber polishing tips and clean away the solder mask. And then we can get a good look at those traces. Yeah, those two traces are definitely broken, as you can see. This one here, I believe that's the data pin for the keyboard. And I'm not sure what that one is. I'd have to check. But let's get some flux on there. And then I can tin these traces and take a look at doing a repair. Okay, and now that the traces are tinned, you can see just how badly those two are broken. And there's also a power rail here that's in kind of rough shape. It's not broken, but I think I'll reinforce it just in case. And as I mentioned earlier, that trace on the bottom, that one is most definitely broken. And check out the discoloration on this part of the board. Okay, here we go. I've got the two traces bodged. Those are the ones going to the keyboard connector. And I'm going to reinforce that power rail as well. Like I say, just to be absolutely safe. May not be necessary, but good idea while we're here. There we go. On the bottom, yeah, I ran a bodge wire over that trace as well. Now, anywhere you see exposed copper, don't worry, that's actually covered with clear nail polish. just as a protectant. And if we fire it back up, let's see if we've got a keyboard. Okay, we got video. And we've got a keyboard. Okay, I've got my 500 meg disk-on module installed. Let's save that info and boot into DOS. Perfect, and we're in DOS. Okay, so just a couple of quick tests here. Make sure everything looks okay. That processor appears to be okay. And I'll check the main board just in case. And that main board looks good as well. Okay, so at this point, this board is essentially fixed, but there's still a few things I would like to do with it. I've replaced that 386 chip with a nice ceramic package. Hopefully I can find a coprocessor to go with it. I also installed a socket for that real-time clock NVRAM chip. One of the pins broke off when I pulled that chip off the board, so I actually had to replace the chip itself. Now, I considered doing the same thing with the keyboard controller, but those 40-pin dips can be a bit of a challenge to remove from the board, so I figured that one works, why mess with it? And then we've got that logic chip. As you can see, there's still some green crusties around the legs of that chip. I really should remove that one, take a look underneath, maybe do a cleanup there, and put that back in a socket. I'm really glad I did. because there was some damage underneath there. Oh, and as you can see, I replaced the keyboard connector as well. Didn't have a new one, so I just threw one on there for now. So yeah, there we go. This board is fully repaired and lightly customized. If you have any ideas what I might be able to do with this one, drop a comment down below. Beyond that, thanks for watching. Feel free to like and subscribe.